explore humans in space. It is the lost lessons of Christa McCullough, in particular, the liquids and microgravity. So I want to start with a Teachers in Space video that this kind of announces about what the Teacher in Space program was and the process by which Christa McCullough became to be the first teacher that was to go into space, and then also how Barbara Morgan was her backup. I've worked on the audio on this. I've still got a little bit of feedback and different things in the background, but just bear with me. I think it's an amazing video. The link for it is in the chat if you have issues with this video. Here we go.
Communicating the space experience, sending someone into Earth orbit who could tell us what it's like in our own terms, has long been a NASA goal. And in August 1984, the Spaceflight Participant Program was given the green light by President Reagan.
Today I'm directing NASA to begin a search in all of our elementary and secondary schools and to choose as the first citizen passenger in the history of our space program one of America's finest, a teacher.
Last June, the semi-finalists in NASA's Teacher in Space project met the press for the first time in Washington, D.C. The 114 educators, selected from over 11,000 applicants, spent a week in the nation's capital, becoming familiar with the history of space travel, and of course, taking notes in workshops dealing with various aspects of shuttle flight.
Let's get it red hot.
The next major milestone came in early July, when the 10 finalists were announced. These teachers had survived an extensive screening process, but they had to demonstrate even more right stuff during their 2-week stay at the Johnson Space Center in Houston, Texas. After a series of tests to ensure that they were medically fit to fly aboard the shuttle, the 10 were given a ride on the KC-135, a hollowed-out padded jet that simulates weightlessness for short periods of time. Finally, on July 19th, Vice President Bush made the historic announcement.
Congratulations.
An elementary school teacher from McCullough, Idaho, was selected as the backup candidate, and Christa McCullough, a Concord, New Hampshire high school social studies teacher, will be the one to actually fly in space early next year.
It's not often that a teacher is at a loss for words. I know my students wouldn't think so. I've made 9 wonderful friends over the last 2 weeks. And when that shuttle goes, they might be one body. But there's going to be 10 souls that I'm taking with me. Thank you.
That's great. You can see everything.
Since their selection, your training in Houston. There's been a lot to learn, but they've shown that good teachers make excellent students. During her shuttle flight, in addition to keeping a journal, Mrs. McCullough will teach 2 live lessons from space. One called The Ultimate Field Trip, and the other, Where We've Been, Where We're Going, Why, which will be broadcast via satellite to schools around the country. She will also do a number of other experiments that will be filmed for classroom use after the mission is complete. Her goal?
I would like to humanize the space age by giving a perspective from a non-astronaut, because I think the students will look at that and say, this is an ordinary person. This ordinary person is contributing to history, and if they can make that connection, then they're going to get excited about history, they're going to get excited about the future, they're going to get excited about space.
While Christa prepares for her flight, life goes on in Concord, New Hampshire, where she has taught for the past 5 years. Understandably, things at the McAuliffe house have changed. For example, there's now a noticeable path from the freezer to the microwave. But husband Stephen, in turn, daughter Caroline, and son Scott have taken on their added responsibilities without reservations.
You know, you're talking about a human being being free of the bounds of gravity, orbiting the Earth. There aren't many human beings that have done that. So I think both of us feel that whatever the price in terms of readjustments or my taking on things that I probably should have been doing before anyway and hadn't done, whatever those prices are, they certainly pale in comparison to the opportunity.
Visit Concord High, and you'll immediately understand what a special teacher Mrs. McCullough is. Former student Andy Barton
Even though Mrs. McAuliffe was a great economics teacher, I think what I learned most from her was outside the classroom. She taught me that the little person counts and that anyone can make an effect on our society and on the world. She proved that by being the first private citizen in space and being the first teacher in space. And I think she's a tribute to her profession, and we're all very proud of her.
Even amidst the excitement of witnessing she doesn't forget her students.
I mean, the whole thing is so gorgeous. You just want to bring it all back into the classroom for the kids.
Teacher in Space project started in 1984, and it ran through 1990. And it was a NASA program announced by Ronald Reagan, as we saw there in the video. And it was designed to spur student interest in mathematics, science, and space exploration. Teachers would train for 5 months, and then after they flew their mission, they would continue teaching in the classroom. That was kind of the setup. They were not official members of the NASA Astronaut Corps. The National Astronaut Corps trained typically around 2 years to prepare for a flight. But President Reagan announced it, the first citizen passenger to fly. There were 11,416 applicants, and that was narrowed down to 114 semifinalists. There were 2 from each state and territory, as well as representatives from the DOD and DOS overseas schools, and also the Bureau of Indian Affairs schools. 59 men, 55 women, and the 10 finalists, as they announced, did go on to Johnson Space Center for further training. And here is where Vice President Bush actually announced that Christa would be the first citizen to fly into space. And the little picture inset there is of Christa and Barbara Morgan, her backup. One of an amazing quote by Christa is, "Reach for it, push yourself as far as you can." And whenever you think from a field of over 11,000 that Christa McCullough at the age of 36 became the first teacher in space, it truly does drive home the fact that we really can do anything. These are some photos from their zero-G training, both Barbara and Christa. The left there, they're playing leapfrog, and on the right there, Barbara and Christa are injecting a hydroponic solution into a cylinder while they're in zero gravity chamber as they practice for one of the experiments that was planned for the flight. Had events happened differently and the Challenger's crew mission completed, Christa would have brought lessons to children around the world. The lessons were prepared, they were rehearsed, many had gone over many times, but they were never performed. And in addition to the live lessons, Christa had planned 2 demonstrations. Filmed during the activity would have been 2 live lessons. One of those I showed at the very beginning, and then the other one is called Where We've Been, Where We're Going. And that was a video. And this here, I actually have a video run through. NASA, they do lots of redundancy. And so prior to ever doing it out in space, they practice here on Earth. And that model holds true today, even for spacewalk missions aboard the space station. So this is some footage from where they were rehearsing where we've been and where we're going. Here's the link to the YouTube video in case there are issues.
Okay, now, Judy, can you zoom out until you can get me in the picture? And then hold it? It'd be nice
so the widest
to end with the space station.
Christa, the widest frame should be from the edge of the lockers to the galley. You weren't, in other words, you weren't going to try and frame just the blackboard. It's all right if we frame outside the backdrop and get some of the lockers and stuff. You just need the backdrop for
contrast, so that you can see things. And what we were planning on doing, and I don't even know whether, I mean, we're assuming that it's going to work. When I show the pictures, we were planning on doing this and having me move rather than have you try to zoom in and out.
Okay.
Because, see, the space station's big enough, and I want some space to be able to do a couple things with it. and the modules that are going to be used for experiments, and the waste module, or the one that's going to be taken off, and how the shuttle links up to it. So as I'm putting it together, and then I wanted to be able to let it go, you know, and show how it's going to look in space, because I think it's hard for kids to realize that you can build something that's not attached to anything. But in zero gravity, you can do that, or, you know, in space, you can do that. So at that point, I wanted to be able to let it go. And since I'm talking about why we're in space and why it's important that other people get a chance to fly in space because of companies and experiments, it would be natural to use him.
Terrific.
Okay. Judy and Ellison and Ron and Dick, of course, the Tidris and the Spartan have already been launched, and the Spartan's already been retrieved. And I'm going to be talking about those, but Barbara's going to be spending some time, and we're hoping that she gets an opportunity to spend some time on Mission Watch and go into more detail, because I only have 15 minutes to do that.
Challenger Houston, we have good video. We're ready for your lesson. Go ahead, Christa.
Okay, we've come a long way from the Wright brothers plane to the shuttle. All right, now, when I've got the shuttle in my hand, that's when I'll start talking about, I probably will talk about the payload bay, and talk about the satellites that are deployed, and then talk about what can be done on board inside the shuttle. I'm going to be mentioning the student experiments that are going to be down here to my right, and I'm not going to be showing them, but I'll mention that there are 3 student experiments on board, because all of them have been put back on board, and I think it might be fun for the kids to know about the chicks in space, because they can certainly relate a lot better perhaps to eggs than they can to the other 2 experiments. All right, so I'll be doing the liquid, marshmallows, otherwise known as cotton balls, and beans. And those things don't even have to be brought that close. I think they'll be able to see that. Okay?
Are you going to mention that the kids can be doing this in their room right now or something like that?
Well, I don't want to mention that, because if I do that, they'll probably be in an auditorium or something. The teachers can do that afterwards if they want to. Whoops. Oh, the zero gravity environment is just awful. Okay. And then I'll be showing how fluids look before I do the micron beads.
So while not a finished product, the fact that we have these moments in time whenever they were prepping, and yes, having to deal with gravity. But for me as a child, I looked up to Christa McCullough. She was by all means a hero and inspiration. And I'm honored that in the 2017-2018 school year, 2 Educator Astronauts, Ricky Arnold and Joe Acaba, finally completed the lost lessons of Christa McCullough. And all 6 experiments had already been scripted and had been made available, including a materials list and step-by-step instruction for teachers. And so part of what we're talking about today is what she would have done 35 years ago. These activities, teachers can replicate what Christa was not able to share from orbit. Christopher's wonderful teaching gift and spirit are captured in videos. And yes, Ariana, as you say, the enthusiasm from her teaching is so obvious. And her remarks and actions in training, accomplishment, and most importantly, her lesson plans. Pre-flight lessons were designed for teachers to use in the classroom to prepare them. You know, students who experience the lost lessons will be the future that continue to be touched by Christa's gift of teaching. While we lost these 7 amazing astronauts on that fateful day of January 28th, 1986 on Challenger STS-51L, we still wish to hone their efforts and their memory of inspiring students. And a lot of that has been done by honoring their families, honoring their memory through the Challenger Center. And we'll speak to that a little bit later on. I'm privileged to have Denise Kopecki, the Vice President for Education for Challenger Centers, we'll talk to in a few minutes. But the families of all 7 on board felt the importance of education. So today, let's focus a little bit about the one that we're supposed to be looking at, and that's liquids and microgravity. The essential questions for this activity is, how do liquids behave and mix in microgravity compared to on Earth? What is density? How does density affect the interaction of different liquids? And the overall objective is compare how liquids behave and mix in microgravity with how they behave on Earth. And the really cool part is that because there are videos that have been made by Ricky Arnold on board the International Space Station, the students can actually compare what they do on Earth with what is being done in space. Yes, these are aligned to NGSS, and there are SEPs involved. So kind of an outline, we'll talk about prep and setup. We'll talk about an opening demonstration that you as the teacher would do. And then there's the video that they would view called Liquids and Microgravity, and we will view that today. And then while they're doing the video, students actually observe and take notes. There's a 4-page handout that goes with this. Then there's some station activities, class discussion, and then application extensions. They kind of use the 5E model. The materials needed for this are not astronomical. To me, they're very common. The opening activity, they have you do salad dressing, and they want salad dressing that has ingredients that separate from one another, so think Italian. For the actual experiment, you'll want clear containers with tightly secured lids, preferably like a jar, oil, water, spoon, and food coloring. And then for the extension, you'll need a pipette, jars or graduated cylinders, again, more food coloring, and then multiple types of liquids. Think different viscosities, different densities, vinegar, honey, various oils, and so forth. The teacher preparation part, to save time, you want to consider prepping the jars for the students ahead of time. And also it really depends upon the level of students that you have in terms of whether you have the students make the jars as shown or whether you as the teacher do that. The containers should have equal parts of oil and water. So the one on the left, it's a third water, a third oil, and a third air. So oil and water mixtures are equal. On the right-hand side, you've got half oil, half water. Again, the oil and water mixtures are equal. The water should be dyed with food coloring to make it easier to differentiate between the liquids. And you can either do this by having a large container of water already with the food coloring in it for the entire class, or you can let the students color it their own. I will say, as experience as a classroom teacher, if you can get by not giving the students the food coloring, your food coloring budget will not be as expensive. I find that students, instead of wanting to tint the water, they prefer to color it, and there is a big difference between giving it a little tint and giving it a solid color. Provide materials for groups of 2 to 4 students, and then the jars for each group will be filled as illustrated below, and there are some more detailed information. These handouts, there's four sheets. I really like them. They've got some great leading questions, some great diagrams. I think they're very easy to follow. Even in a virtual environment, if you had students who had to do the activity on their own, I think that there's enough guidance with this that they could do that. Now, obviously, you lose the group aspects of things, but I do think that it's absolutely still a doable thing. So the engage aspect, have students in small groups with salad dressing. Again, ask them not to pick it up. Part of the deal is you don't want it shaken up just yet. You want to go ahead and see it while it's separated out. I will say, I had, when I taught, we were near a Coca-Cola plant, and I was able to get some like test tube bottles that had the Coke lids on the top of them. And so it was, I could fill that with a liquid instead of having to have a full 16-ounce or 24-ounce bottle of salad dressing, so that it would go a longer way. But you want to ask students to discuss within their group what ingredients that they might find in the dressing. Students should note that there are layers of liquids or ingredients in the bottles of dressing. And if they're real smart, they'll actually just look at the label and see what the ingredients of the dressing is. But you want to challenge the students to think about what the different layers are, have them briefly share together within the class, and then have them shake up the salad dressing, set it back down, and observe what happens. If the salad dressing has been opened before, or you are using reusing bottles, for example, if you bought it in bulk and then put it into your own plastic bottles, I would highly recommend taking some hot glue and actually sealing the lid so that the students can't accidentally have it come off. Ask students to discuss in small groups or as a class, why do you think the ingredients separate again? And obviously, if you can do this prior to teaching the concept of density, the timing could be ideal. Now, in addition to the actual video, the students, in terms of the actual activity, students can actually watch a video, which we're about to see. And this is Ricky Arnold explaining the demonstration for the liquids in microgravity. Students should observe and take notes. Matter of fact, the handouts that they have actually have some questions regarding the video. And so let's watch it now. Again, if you need the link, it's in the...
This is Christa McCullough, live from the Challenger. Teachers are excited about this.
Alka-Seltzer in the container.
Look at that bubble.
Here's your reaction.
The whole country was invested in that mission. We're going to have the opportunity to kind of bring that mission full circle.
Hi there. My name is Ricky Arnold, and I'm living and working on the International Space Station as a part of Expeditions 55 and 56. As part of a year of education on station, we're going to look at the effect of microgravity on the behavior of liquids. Specifically, when we try to mix certain liquids with water, why do some of the liquids we add sink below the water while others float on top? The answer largely has to do with density. Density is how compact something is. Think of a golf ball and a ping pong ball. They're almost identical in size, but when dropped in water, a ping pong ball, as you know, will float and a golf ball will sink. That is because the ping pong ball is less dense than water and the golf ball is more dense. So what happens up here on the ISS and microgravity? Let's find out. So, just like the experiment you're going to do on Earth, I took some water and I added a little bit of food coloring to it. And here's our water, and here is our olive oil. And look at that, it's separated very nicely. And as we talked about, there's two things happening here, one of which is that the oil, which is just a fat, part of it likes to avoid water, and part of it is attracted to water, so it forms this thin film. And actually, if this water was spread out, the oil would just spread out along the surface, just like it does in an oil spill. And down on the bottom, we have water, which is the more dense substance here, just as we would expect. And this is probably what you saw happen on Earth. Now, I know the experiment has us want to shake with bubbles and without air bubbles. Well, air bubbles are a problem on the space station. Fluids just do not behave like they do on Earth, and it took me quite a while to set this up. But that's okay, because the scientists who send experiments up here, we have trouble with the way water behaves and the way liquids behave here all the time. Even in our spacesuits, air bubbles are a problem. Because on the surface, air bubbles are really, on the Earth, air bubbles are really easy to get rid of. They float to the top. Up here, they're far less interested in floating and more interested in just kind of staying where they are. And again, this has to do with, in a microgravity environment, the density just doesn't matter as much. And you can see a lot of small bubbles trapped in the oil here. Not so much in the water, but a lot of them trapped in the oil. My guess is there might be a thin film of water near these air bubbles as well, as this accidentally mixed while I was putting it together. Not to worry, this happens. This is something that scientists up here have to deal with all the time. So let's go ahead and shake this up and see what happens with the bubbles and see what kind of mixing we get. And the air bubble actually helps to force. You can see the air bubbles became much smaller, but the movement of the air bubble within the liquid helped to disperse it. My guess is over time, this won't separate as well as it does on Earth, because the air bubbles don't really want to float in a specific direction, so they tend to become stuck in solution. Well, something you can't get away with on Earth is I just mix these differently, and this is the exact same thing, except we have on the top, we have the water with a little bit of food coloring, and on the bottom, we have the oil. I don't think you're going to be able to make this happen on Earth, but it'll be interesting to see if you can try. What is happening here, I think, is that density plays less of a role. And then what is actually more important up here in microgravity is the chemical property of the fat and the water that's making this behave in this way. And it's more interested in staying apart and forming a film and a protective layer between the two substances than it is in mixing and worrying so much about density, even with just a little bit of force like this. Here's something else I noticed, and that was just as well. I was just trying to get ready today. Here we have a nice separation of the fat and the water, but if I actually apply a force to it, in this case a downward force, a centrifugal force, I think I can get these to move. So I'm going to go ahead and move my arm, and I'm going to have the force pushing down this way, and let's see what happens. Okay, the more dense water stays. Now let's flip it around and see if we can get the oil to move. So the centrifugal force should be pushing the water down toward the more dense water down in the direction of the force. Look at that. My hands are all covered with vegetable oil, but the oil has now moved down to the bottom and the water is floating on top. So density played a role when there was a force being applied. In this case, it was a force that I was generating, like a miniature centrifuge, and that caused the more dense water to come up in the direction of the force over the less dense fat. We can also move the fat back to where it began just by applying the force in the opposite direction. So we want the water to go this way, so we'll move it toward the handle of the syringe, the plunger of the syringe. That's pretty cool, and there it is. So we've got the oil back where it belongs and where it would be on Earth, floating on the surface of the water. Now it's your job to see what happens on Earth. Thanks for participating in our experiment today. Signing off for now, I'm Ricky Arnold. So long.
So I think that's an amazing video, and even it's on YouTube, also available on challenger.org. But having the students, after you've shown the video and they've reviewed some of those questions, made some comments that they're going to do an in-class experiment. And this is where they will make the water-oil mixture and then the water-oil-air mixture. And again, I'll go back and say, make sure that it's equal parts of oil and water. So half and half, or a third, one third, one third. There are 2 worksheets. There's actually 4 worksheets totally, but you can see here that you've got a few questions that kind of come from the video, and then they go into the activity. And you can see where there's container observations, the jar with no air, and then the jar with air. And then, again, following the 5E format, you'll elaborate and evaluate. There's a conclusion where they can talk a little bit about which is more dense, oil or water. They can review questions. If you bring them back as a group, and then have them talk about them. And what you want to get to is the fact that, water is more dense than oil. And the experiments in space and on Earth look different, and that's due to the strong sense of gravity here on Earth. Gravity pulls denser, heavier substances to the bottom of the container over time here on Earth, but this does not happen in microgravity, which is why the air bubbles stay trapped in the water. And they can also examine a bottle of that salad dressing that's been sitting on their desk and have them to think about if you shook it up on board the ISS. You know, do you think it would settle into layers as it does here on Earth? Why or why not? So some great questions of inquiry. As an extension and additional enrichment, give the students the opportunity to mix new substances to determine which substances will combine with one another and which ones will separate. Provide students with additional jars or graduated cylinders that they can try to layer liquids or mix them up. Students, again, may want to add food coloring to substances to be able to tell which substance is which. Encourage students to record what they add to the mixtures, observe which substances are more dense, less dense, and then, you know, which ones combine together and which ones do not. And then come back in as a group within the class and share. That picture over on the far left, that's Scott Kelly, and he's demonstrating effervescence on board the International Space Station. And there's actually, yeah, absolutely, I think that would be a great one. There's actually a video of Scott Kelly with that effervescence. But the goal of that video was all about experimenting with 4K cameras. And so my video does not do it justice, but decrease the quality for you to see it. But the actual live link in 4K. That's him actually adding an effervescence tablet to it. And again, the video in 4K just jumps off the screen. I'm limited here in terms of how much we actually show for the simple fact that I have to have the quality low enough that regardless of what your internet bandwidth is, you can be able to still access. So I want to now introduce Denise, and she's the Vice President of Education at the Challenger Center, or for Challenger Center. And Denise, I'm going to turn this over to you and let you share, and we'll go from there.
Great, thank you, Barbie. Well, it's nice to see everyone tonight on the webinar. As Barbie said earlier, Challenger Center was founded in 1986, just a few months after the accident, actually, by all of the families of the Challenger crew. They really wanted the legacy of their loved ones to be carrying on the educational mission that they had all felt so strongly about. So we have, this year is actually our 35th anniversary, and we have several different programs that we do for students. We serve about 250,000 students a year, and we have experiential STEM programs for kids, and we're going to talk about the 3 different areas that we do that in just a moment. But so far to date, we have served a little over 5.5 million students around the world, and we have 40 Challenger Centers in the U.S. And several that are abroad. So we will talk about that in a minute as well. Oh, Barbie pulled it up. So the 2 that are in red are coming soon. They are actually opening this year. One is opening in the fall of 21 in Pennsylvania, and then we have a center in Michigan that is opening in early 2022. If you see a Challenger Learning Center on the map somewhere near you, as soon as everybody is back in person, they would love to see you. And if you don't have one near you, we actually have some programs that you can still participate in with your kids. So one of the things that the families wanted to do. The family member of Dick Scobie, the commander, his wife June was actually a science educator as well. And so June worked with Barbara and Christa before the launch to work on the lessons as well. Barbara still serves on our board today, and so I talk to her quite often. And we actually have several of the astronaut educators involved in our organization now. We worked with Ricky Arnold and Joe Acaba to bring these lost lessons to life. Ricky felt really strongly that that was the special project he wanted to do while he was on board. Christa made a really big impact in his life, and so we were really excited to do that project with him and Joe when they were on board the ISS for the Year of Education on station. So the 3 core programs that we offer at Challenger Center are all part of experiencing careers and space science and STEM in general in a hands-on way that really puts kids in the role of being a really important part of the mission that they're on. So we have our center missions, and that is located at our Challenger Learning Center, so on that map that we just shared with you. And you can see the picture there of students participating in the mission. If you were here a couple minutes early, you saw the video, which is also linked in the deck you guys can watch. But students participate in a simulated space mission. So the kids go in, and half of them go into mission control, half of them go into the inside of the spacecraft, and they work together as a collaborative team. They each have a different role and job to do. They might be a geologist, a navigator, a medical doctor, a communications specialist. There's all kinds of different jobs that they're given. And they work with their counterpart in mission control in the spacecraft. There's always an emergency in our programs that force students to work together in real time to serve the emergency. So all of those are space themed, and they are geared towards middle school students in grades 5 through 8. We have another program called Classroom Adventures, which takes STEM a little broader. They are not all space-based missions. Those are for upper elementary school students in grades 3 through 5, and those are meant to be done when students are in person in a classroom, which we know is not the norm right now. But these adventures let kids explore different science topics like ocean science and ecology and plant systems, weathering and erosion, things like that. And it's designed to be the opening to your science unit so that they have a great adventure to pull back to as you teach, as a much more experiential way to open your unit instead of, watching a Magic School Bus video or something like that. This gives them something to work towards together as a team. And then we have virtual missions. Virtual missions are new to us, and we're actually born out of the pandemic. We wanted our centers to still be able to serve the communities that they're in and to reach students that we can't normally serve. And so the virtual world gave us an opportunity to do that. So we created virtual missions also for grades 5 through 8. However, we do have several schools that have used them with 4th graders and a whole lot of schools who have used them with high school students as well. So we have 2 different virtual missions. One is Destination Mars, and that is actually led by Dottie Metcalf-Lindenberger, one of the other Educator Astronauts for NASA. She actually serves on our board of directors, and she is the leader of that mission. And she takes the kids through the decision of whether or not they should build a base on one of the moons of Mars, on either Phobos or Deimos. And she works with them to do that. And I think Barbie is going to show the teaser video for that right now so we can look at Destination Mars.
Your primary goal today is to help us identify which moon offers the best possible location for our human habitat.
virtual missions, if you caught in there, they are run by one of our trained flight directors at a Challenger Learning Center facility. So you as the teacher get to experience it with your students, which is really fun. You get to pop in and out of the rooms where they're chatting and really get to observe your students in a way that you don't often get to do in the virtual classroom. So there is a link up here and will be in the deck that you all can download. This is the information page if you would like to do a virtual mission with your students. We also have a second virtual mission called Destination Moon, which is designed for 7th and 8th graders. That one we did in concert with Blue Origin, and it is students launching Blue Origin's rocket New Glenn with Blue Moon, the lunar lander, as its payload. Students will go through all of the stages of flight to get that payload landed safely on the moon. And one of the designers of Blue Moon and New Glenn, one of the engineers, Adam Worrell, is the person who leads that mission for students. So we hope that you guys will join us in some way at Challenger Center. There's many ways to connect with us that are there on the screen. And we hope to serve some of your students and you in the future as we continue to carry on the legacy of Christa and the rest of the crew. I'll turn it back over to Barbie.
Thank you. Thank you so much, Denise. I so appreciate you taking the time to not only join us, but by all means help to share the news in ways that educators can get involved. I do want to say that I have included some slides about each one of the 7 astronauts on board Challenger, just to give you some background, some additional slides. And then I also want to talk a little bit about the fact that that while the Challenger Centers, yes, it started because of Space Shuttle Challenger, but there are also ways that they also honor the astronauts that we lost in Apollo 1 and also the astronauts of Space Shuttle Columbia. As a matter of fact, I've been to the Columbia Center, Challenger Center out in California. That allows specific, that one there was specifically there for Columbia. So it's not just Christa or just her team members, but all of those that have paid the ultimate sacrifice for the ability for us to continue exploring into space. And while ultimately Christa McCullough was the teacher in space selected and Barbara Morgan was the backup, Barbara Morgan went on to be selected as a mission specialist as a part of NASA Astronaut Group 17 in 1998. So while originally she was selected as a teacher astronaut, and that would have been just for the 5 months worth of training, but she actually went on to be accepted into the Astronaut Corps as a full-fledged astronaut. And although she's often referred to as an educator astronaut, she was actually selected as a mission specialist. She flew on STS-118 in August of 2007. And while it was 21 years after Christa, she was a fully trained astronaut as part of the Astronaut Corps and had the same mission specialist duties as all other mission specialists. The difference was she was the first astronaut that had been a former classroom teacher. The Educator Astronaut program, or Astronaut project, was the predecessor of the Teacher in Space program in January of '98. This carried on the objectives of the Teacher in Space program, seeking to elevate teaching as a profession that inspires students. But unlike the Teacher in Space program, Educator Astronauts are fully trained astronauts who do the same jobs and duties as any other astronaut, and they fly as crew members with critical mission responsibilities as well as educational related goals. In addition to their technical assignments, they assist other astronauts in connecting to students and teachers through space exploration. And educators who will ultimately inspire the next generation explorers, as truly only NASA can. The astronaut class of 2004 was the first class to have educator astronauts. And in 2004, those 4 educator astronauts were Joe Acaba, Dottie Metcalf-Lindenberg, which we just heard from with Mission Moons, and then also Ricky Arnold. And we've already heard from Ricky earlier tonight as he and Joe participated in the Year of Education on Station, where they actually did the Christa McCullough Lost Lessons. And there's an inset there in the upper right-hand corner of just those three. But in 2004, that was the first class where there were Educator Astronauts. And NASA does not call them former educators. They just consider them educators who now happen to be astronauts. Happen to be astronauts, yeah. So this opened the door for professional educators to apply into the Astronaut Corps. And they have taken educators from elementary, middle, and high school. And Joe, Ricky, and Dottie represent those educators as trained to perform their duties as astronauts. And truly, by doing so, they inspire students who consider careers in math, science, engineering, technology, and maybe someday there'll be students who join our nation's space program. So the Teachers in Space program I referred to earlier with Ricky and Joe, that was back in 2017, 2018. But if you haven't signed up for NASA Express, it's a newsletter that comes out once a week. It basically tells you anything and everything that's going on with NASA education. I will tell you that as a classroom educator, it is the one email each week that I made sure I read, just because it comes just chock full with so many different things that can be used as a student, as an educator, as a parent, as a learner. And I want to close today with a video that is Why Do We Explore? And I think it'll help kind of, well, to me, it's inspirational even beyond what Christa is. But why is it that we're willing to go and explore? And, you know, as an educator, the work that you're doing to help inspire the next generation of explorers.
Roger the pitch. 7, 6, 5. Roger, roger. You're looking good. 3, 2, 1.
We are the explorers. We have a need to find what is out there. It is a drive inside each and every one of us. The drive to wonder, to push the boundaries, and to explore. We expanded across our lands, settling new frontiers. We took to the oceans and learned that we could cross treacherous expanses in the pursuit of discovery. And then we took to the skies and flew. But that wasn't enough. We left the planet and redefined what was possible. We flew in space. We walked in space. What once was a melodramatic flight of fantasy became reality. Then, a new generation of spaceships captured hearts and minds for 3 decades and helped build a castle in the sky that is our lasting home in space. We have always looked up. For centuries, we wondered what was on the other side of the sky, and we have begun to answer that question. We have learned that all the exploration humankind has achieved is only a beginning. Right now, men and women are working on the next steps to go farther than we have ever gone before. New vessels will carry us, and new destinations await us. Everything we have ever accomplished leads to this moment in time, where exploration will now take us to the planets and the stars. Our nearest neighbors in the night sky have beckoned us, invited us, dared us to reach for them. We are the explorers. Throughout our history, we have taken both small steps and giant leaps in that pursuit. Our next destination awaits. We don't know what new discoveries lie ahead, but this is the very reason we must go.
And truly what you are doing in your classroom is to helping us inspire the next generation of explorers. And one of my favorite Christa McCullough quotes is, "I touch the future, I teach. And truly, as teachers, that is what you do. You are touching the future. And thank you so much for that.